Uh, Welcome once again in this spoken tutorial on transformer. In this part, we will be discussing the testing of the transformer. Once the transformer is manufactured in the factory, it has to be tested before to be put in the service. So we generally find the efficiency and regulation of the transformer and calculate the equivalent circuit parameters by testing it. So what are the methods for testing the transformer? Generally two methods are used. First is direct loading test and other is by performing open circuit and short circuit test on transformer. Let's see the direct loading test. In this test, load is actually connected to the transformer secondary winding and supply is given to the primary winding, and then meters, voltmeter, ammeter, wattmeter are connected uh, to the primary and secondary both with appropriate ranges of the meters. Then load is increased in steps and readings of primary voltage, current and power, secondary voltage, current and power are noted down. So V1 I1 W1, V2 I2 W2 are the readings of the meters. So this is the circuit diagram in which we see that auto transformer is used for variable supply. Then a voltmeter of proper range, current uh, uh, range, ammeter is used, and wattmeter is used for measuring the primary power. Similar meters are connected in secondary also. So V2, I2, W2 is measured on secondary side. Load is connected, which is variable. So this load, first reading will be at no load, zero load, and then gradually increasing the load in the steps. We note down V1, I1, W1 and V2, I2, W2 as shown in the observation table. Now from these readings, efficiency and regulation can be calculated. Efficiency we know is given by secondary power divided by primary power, that is output power divided by input power. So percentage efficiency is W2 divided by W1 multiplied by 100 at each step, and the regulation is given by V2NL minus V2L divided by V2NL multiplied by 100. So efficiency and regulation can be calculated at each reading. So what are the advantages and disadvantages of this direct loading test? Efficiency and regulation can be calculated easily as all values of voltage and current are readily available. Efficiency and regulation can be calculated at desired load as the load can be adjusted to desired value of current. The main disadvantage of this is that we have to arrange the load in the lab. Therefore, if the large transformer is there, that much load cannot be adjusted in the lab, and therefore such test, direct loading test, is suitable only for small transformers, and the large transformers cannot be tested using this test. Another main disadvantage is that we actually connect the load to the secondary winding, and therefore current flows, full load current flows, and power is wasted during this testing process. Okay, these are the disadvantages, and therefore it is used only for testing small transformers in the lab. Another good method which can be used for smaller and larger transformer both is by OC and SC test, open circuit and short circuit test. In this test, load is actually not connected. The core loss and copper losses are calculated from these tests. Efficiency can be calculated at desired value of power factor and load factor. Equivalent circuit parameters can be calculated from this test. Regulation can be calculated at desired loading factor and the load power factor. So how to perform this test? The procedural steps are: one of the windings, generally high voltage winding, is kept open. Meters are connected in other side. Rated voltage is applied so that the normal flux is set up in the core, and the core losses will be normal core losses. And then readings of voltage, current and power are noted. So this is the circuit diagram for performing the open circuit test on a transformer. As you can see, one winding is open while the meters are connected in another winding, and an auto transformer is used to give the variable supply required for adjusting the rated voltage of the primary. And VOC, IOC and WOC are the readings on this particular site. Now, what quantities can be obtained, calculated from this OC test? First, we get the core loss. The wattmeter in OC test reads core loss, so the copper loss is negligible because the current is only magnetization current, which is about 5 to 10% of the full load current, and therefore at this much smaller current, the copper losses can be neglected, and therefore whole of the wattmeter reading can be taken as core loss Wi. We can calculate from this test the resistance of magnetizing branch R0, reactance of magnetizing branch X0. Second test is short circuit test or SC test. The procedure is like this. One of the winding, generally low voltage winding, is short circuited and the meters are connected in other side. Reduced voltage is applied in this test because if the full voltage is applied, winding can transformer can get burned. So the voltage on applied voltage is adjusted such that the full load current flows in both windings. So it can be up to 10% to 15 or rather 20% of the rated voltage. And then readings of voltage, current and power are noted down. So this is the circuit diagram wherein an auto transformer is used for variable supply to give the reduced voltage to the winding, and other winding side is shorted. Meters are connected in the first winding, and readings of VSC, ISC and WSC are noted down. So what parameters can be calculated from this are, we get the copper loss from this test because the wattmeter in this test reads copper loss. The reason is that applied voltage is very less and therefore core losses are negligible. We can find the equivalent resistance of the transformer referred either to primary or secondary, that is R01 or R02 can be found out. Similarly, equivalent leakage reactance of the transformer referred to either or both windings can be found out, that is X01 and X02 can be found out. And knowing these values, we can find the efficiency and regulation of the transformer. The advantages of OC and SC test are, these are easy to conduct, no need to connect load to the transformer. Power is not wasted during the test as in case of direct loading test. Equivalent circuit parameters can be calculated for further analysis. Thank you.